In this video, we're going to talk about the transformation that is known as a translation. A translation slides an object a fixed distance in a given direction. Those directions could be on a coordinate plane, right, left, up, or down on the coordinate plane. The original shape and its translation are congruent. This is a key word, meaning they are the same shape and the same size. So when we do a translation, the shape does not change shape. It does not get bigger or smaller. Since a translation slides a shape, both shapes will face in the same direction. So we're going to talk about a couple other transformations that are congruent, which means they stay the same shape and the same size. But the difference here is that a translation faces in the same direction. Okay, so that's a key part to identify if a transformation was a translation. So we're going to look at some examples in just a minute in terms of actually sliding the shapes. But in terms of the coordinates, here's how the coordinates will change. If we slide a shape right or left, that will change the x-coordinate. So think about the x-axis works right and left. So if we slide right, our x values will increase, however many units we slide right. If we slide left, our x-coordinate will decrease, however many units we slide left. If we slide up or down, that will change the y-coordinate. If we slide up, that will increase the y-coordinate. Think about the y-axis runs up and down. And if we slide the shape down, it will decrease the y-coordinate. So here's an example of kind of the notation that a translation might be written in. So they'll say x comma y, so this means our original coordinates are going to shift or slide x plus 6, so that means right 6 units, and y minus 4, that means down 4 units. So a little description says this means to slide each vertex of the shape 6 units right and 4 units down. Now we'll take a look at some examples here and see how this actually works. Zoom in here. All right, so let's just look at number 2 to start off with, because number 1 just says 1 unit left. 2 says translation 1 unit right and 2 units down. So here's our original shape. We have T, E, and I, and we have a triangle. So what we're going to do is we're going to slide each of those points, or each vertex, 1 unit right and 2 units down. We're going to put our new point there, and we call that the prime point. Remember, prime means the new point. And then once we have our 3 vertices, we will connect those points and we'll have our new shape. So 1 unit right, 1 unit right, and 1, 2 down. So we'll put a point there and we'll call that T prime. E, 1 unit right, 1, 2 down. Call that E prime. I, 1 right, 1, 2 down. I prime. Now we connect them. And we have our new shape. And that's all you do on a translation. All right, let's look at number 6, okay? Number 6 gives us points, and then they want us to translate it 3 units up. So we'll go ahead and plot our original points. So R is -4, -3. 1, 2, 3, 4, 1, 2, 3. That's R. D is 1, 2, 3, 4, 0. L is 0, 0. And F is 0, 1, 2, -3. Okay, and so we have our original shape, which is a rectangle. And now we're going to slide each of those points 3 units up. So I'll use a different color for this. Okay, so D is going to go 1, 2, 3. That'll be D prime. 1, 2, 3. L prime. 1, 2, 3. So now I'm going to kind of cover that up a little bit. That's R prime. And then F, 1, 2, 3. F prime. Now we connect those. And we have our new shape. So this is our new shape. And that was our old shape. Okay? All right, so now let's flip it over. And let's look at a couple other examples. All right, 7 through 10 are talking about just the coordinates and how the coordinates are going to change based off of translation. So let's look at a couple of these, and here's where we're going to keep in mind that if we shift right or left, it affects the x-coordinate, and if we shift up or down, that affects the y-coordinate. So let's look at 9 and 10. We'll do those two. So here's what I would like to write down. For number 9, it says translation 4 units left. So left means that I'm going to take every x-coordinate and I'm going to take away 4, or I'm going to subtract 4. 4 units up means I'm going to take every y-coordinate and I'm going to add 4 because I'm going up. Okay, so now I'll write j prime. Okay, so now I look at the x-coordinate is -1 minus 4 gives me -5. -2, now the y-coordinate, add 4, gets me to +2. And that's my new coordinate for j. A, we'll call it a prime. Once again, -1 minus 4, -5. 0 plus 4 gets me to 4. Now we'll look at n, we'll call it n prime. We have 3 minus 4, which would be -1, and -3 plus 4, which would be +1. And so those are the new coordinates after we have done the translation 4 left and 4 up. All right, number 10. 3 units right is going to tell me to add 3 to x, and 4 units up, once again, add 4 to each y-coordinate. So now we look at z, and we'll call it z prime. -4 plus 3 will give me to -1. -3 plus 4 give me to +1. Now look at I prime. -2 plus 3 give me to +1. -2 plus 4 give me to +2. And the last vertice, v, we'll call it v prime. -2 plus 3 gives me to +1. And -4 plus 4 gets me to 0. And that's all I would do on those. All right, last type of problem we'll look at are writing a rule to describe the transformation. Okay, so let's look at 12 and 13, because if you notice 11 and 12, or 11 was just shifted up and 14 was just shifted to the right. So we'll look at a combination. So let's number 12 first. Okay, so the first thing we want to look at is where the primes are. So that's d prime, I prime, f prime, and k prime. Okay, so that tells me this is our new shape. That is our original shape. That's helpful for me to know because my answer would be the opposite if I got the two shapes mixed up. Okay, so if we we know that each point is going to move the same distance. So let's go from D to D prime. So it looks like we're going to go down 1, 2, 3. So that looks like down 3, 1, 2, 3, and then right 1, 2, 3, right 3. And that's our rule. Now we could say we went right first and then down. That's the same thing. We're gonna end up in the same place, okay? Now if we wanted to write it in the notation, we could say x comma y with an arrow, okay? And then right 3, we'll list to right first because that's going to be our x coordinate. We'll say x plus 3 because we went right 3. And then down 3 would be y minus 3. And we'd put that in parentheses just like that. All right, let's look at number 13. Once again, locate your primes. So we've got E prime, L prime, and B prime there. So that tells me this is our new shape. That is our original shape, okay? So it looks like we're going, let's go from L to L prime. Left, 1, 2, 3, 4. So left, 4. And then we're gonna go up 2, okay? Now we could say up 2, then left 4, it's going to be the same thing. We'll write our notation, x comma y, and left 4 means x minus 4, and up 2 would give us y plus 2, okay? And that's pretty much all for translations. Remember, the key part of a translation is that it slides, the shape stays congruent, meaning same shape and same size, and specifically to a translation, the two shapes will face in the same direction. That's a translation.